Hi, Algebra 2. This is Unit 13, Lesson 3, Statistics, and today we're going to talk about the normal distribution. So this is a big part of statistics for Algebra 2. Lots of questions on the regions. So many populations have a distribution that can be well described with what is known as the normal distribution or the bell curve. The curve shows the percent or proportion of a normally distributed data set that lies certain amounts from the mean. So this is a normal distribution based on standard deviation. So I colored each of the you see how I have 0 in the middle right there. The 0 always represents the mean, so you can add the mean right in. And I've broken this down by halves. So to the right of 0, I have 0.51, 1.52, 2.5, and 3. Well, each of those steps represents a score that is half a standard deviation above the mean. But I also, even though they're broken down by halves, the two halves I colored the same color. So like the yellow is 1 standard deviation above the mean. The orange is a second standard deviation above the mean. And the two greens, there's not a lot of scores in them, but that's 3 standard deviations from the mean. And I have 0 in the middle. If I go to the left of 0, I have negative 0.5, negative 1. So together, the two blue, steps right there are 1 standard deviation below the mean. And then the two that I have highlighted in pink are another half and a half, so that would be 2 standard deviations from the mean. And then I have the 2 green on the tails right there. We call those ends the tails. So you can see that the percents in there, all right? So 19.1% of the scores in a normal distribution are a half of a standard deviation from the mean. And same thing, 19.1 is a half a standard deviation below the mean. Another half, okay, so the 19.1 plus the 15, all right, so together that would be 34.1. So these two together right here is 34.1%. And to the left of the mean, all right, so below the mean, again, I have 19.1 and 15. Together, that's 34.1% also. So all the scores that are 1 standard deviation below the mean and 1 standard deviation above the mean, so those are the ones all that I have circled in purple right there. I added them together. It's 34.1 and 34.1. That's a total of 68.2. So we're going to write that down below. I just wanted to explain this normal distribution. In a normal distribution, half the scores or 50% of the data is below the mean and 50% of the scores are above the mean. All right? So a lot of times, you can go by halves. A lot of times we're going to go by 1 standard deviation, 2 standard deviations, 3 standard deviations. But you can definitely do the halves. I just have it, so I have it broken up by halves, the percents, but you'll be adding those percents together. So each percentage represents the approximate proportion of the data that falls in that range of scores in a normal distribution. It is the probability that a score in that section occurs. So, now I already did this. 68.2% of the scores lie within 1 standard deviation of the mean. Now, how again did I get that 68.2%? I added the 15, 19.1, the 19.1, and the 15. So I looked at 0, and I went 1 standard deviation to the left, which means I added the 19.1 and the 15, and 1 standard deviation to the right, and I added 19.1 and 15. So in a normal distribution, 68.2% of the scores lie within 1 standard deviation of the mean. In a normal distribution, 95.4% of the scores lie within 2 standard deviations of the mean. Now, how did I get that? Let me grab another color. So within 2 standard deviations. So basically I added 4.4, 9.2, 15, and 19.1. So I added those 4 scores together, and then I doubled it because I have the same exact 4 scores on the left side. So within 2 standard deviations, basically I added all the numbers that are in the pink, the blue, the yellow, and the orange. Because see on the bottom, that's 2 and 2. So I wanted 2 standard deviations below the mean and 2 standard deviations above the mean. And if you were to add all those scores together, that totals 95.4%. This is going to be an important one that will come up a lot, all right, because the majority of our scores should be within 2 standard deviations of the mean. Yeah, because 95.4 is the majority of the scores. Now, when I go out to those little tails, the ones that I have highlighted in the light green to the left, to the right, and the darker green to the left, I'm just adding a little bit more. So I would have the 1.7 and the 0.5, all right? So let me get a red. So I'm adding this, plus all the ones that I already added up. Okay, so if you add up all those percents that I have in red, it's everything but the 0.1 and the 0.1. It's 99.8% of the scores lie within 3 standard deviations of the mean. In a normal or bell curve, we use the mean and the standard deviation to break down the data into percentiles. A percentile, it indicates the point below which a percentage of the data falls. In a normal curve, the mean is the 50th percentile. All right, so let's look at some problems. Filling in the normal curve and determining percents and probabilities. So that's what we're going to look at here. On a standardized test, the mean was 82, so that's going to go right smack in the middle. And the standard deviation was 6%. So I'm just doing 1 standard deviation, 2 standard deviations, and this is 3 out here. I'm not going to do the halves here. All right, so 1, 2, 3. The standard deviation was 6%. Determine the scores for the 3 standard deviations within the mean. So all I'm going to do is going to take the 82 and I'm going to add 6. That's 88. That's 1 standard deviation. Add 6 again. That's 94. That's 2 standard deviations. And then I'm going to add 6 again. So that's 100. All right, so this was 1 standard deviation. This was 2 standard deviations. This was 3 standard deviations. Then I have to do the same thing to the left. So I'm going to subtract 6. Now, why am I doing that? Because the standard deviation was 6. Subtract 6 and I get 76. Then subtract 6 again and I get 70. And subtract 6 again and I get 64. So again, that's 1 standard deviation, 2, and 3. So what are the scores that are within 3 standard deviations of the mean? That means 3 standard deviations below the mean and 3 standard deviations above the mean. Well, those scores go from 64 to 100. So that's how that works. A little bit different problem. Determine the standard deviation for the normal curve drawn below. All right, so this is the mean in the middle. They actually didn't give me the mean. I got to figure the mean out, all right? But 1 standard deviation away from the mean is 12, and 1 standard deviation above the mean is 40. Well, to figure out the mean, it's actually not too hard. I'm going to add the 12 and the 40 together and divide by 2. So 52 divided by 2 is 26. All right, so that's the mean. And then, but they wanted me to determine the standard deviation. So 26 plus what is 40? Well, that means my standard deviation was 14 because I added 14 and I subtracted 14. I added 14 to go this way and I subtracted 14 to go that way. So my standard deviation is 14. Another way that I also could have done that is just done 40 minus 12, take those two numbers right there, and divide that by 2. That will also give me the same answer, 14. All right, a normal distribution has a mean of 84, so 84, the mean's going in the middle. It has a standard deviation of 5. What's the probability that a randomly selected value from the distribution is between 74 and 94? All right, well, let's figure this out. So one standard deviation, this is one standard deviation. I add 5. And, oops, I didn't add 5 there, 89. And then I add 5 again, and that would be 94. I add 5 again, that would be 99. So again, this is one standard deviation, 2 standard deviations, 3 standard deviations. And I'll do the same thing going the other way. I subtract 5, and I'll subtract 5, and I'll subtract 5. How many scores are between 74 and 94? So 74 and 94, right there, okay? That's 2 standard deviations. If I go back to my numbers right here, which you're going to get used to these numbers, what percent of the scores were within 2 standard deviations? 95.4%. Okay, so that's my answer, 95.4%. So you do have to know those numbers. I'm going to show you how to do it on the calculator as well, though. All right, a normal distribution has a mean of 51, that goes in the middle, a standard deviation of 3. So one standard deviation is 54, add 3 again, and add 3 again. Subtract 3 is 48, subtract 3 is 45, subtract 3 is 42. All right, what's the probability that a randomly selected value from the distribution is at most 48? So at most 48 means I want everything that is 48 or below. All right, so if you remember, you can add all these that I just highlighted in yellow. The whole normal distribution is 100%. Okay? I want this part, remember half is 50%. So let me just get a different color. This part right here is 50%. If you remember back from our curve, this part right here was 34.1%. One standard deviation below was 34.1%. So this right here is 34.1%. So the part that I don't want is 84.1%. So I can just do 100% minus 84.1%. And I want at most 48. So I really want everything below that. And that's going to be, what is that, 15.9%? Did I subtract that right? I think I did. All right, and that would be the same as if you just added, and I'm going to get rid of all this highlighted so we can just go back and look at this whenever we want to. I wanted at most, let me go back, at most 48. So basically, I wanted everything up to the 1 standard deviation. So if you're doing it this way, I'm adding this and this and this and this and this. I wanted everything up to this. That's what I was doing. So if you add all those percents up, I would get the same thing. All right, on a standardized test, a score of 75 falls exactly 2 standard deviations below the mean. All right, so here's the mean right there in the middle, and 75 is exactly 2 standard deviations. If the standard deviation for the test is 4, what's the mean score? Oh, this isn't too bad. I'm going to add 4, and then I'm going to add 4 again. So my mean is 83. Let's see if you understand that normal distribution, then these are not too bad. If 95% of the scores on a normally distribution test fall between 75 and 91, what's the standard deviation? 95% is about 2 standard deviations. Okay, 2 standard deviations was 95.4. But we're going to say it's about 2 standard deviations away. All right. and 2 standard deviations. So here's my mean. Boom, boom, 2 standard deviations. 75 is the lower score and 91 is the upper score. All right? So you have to figure out, I mean, there's 2 ways to do this. You can just add those and divide by 2 to find out what the mean is in the middle. That's one way to do it. Or if you subtract them, 91 minus 75, divide it by 4. Now, why 4? Because I basically have 4 sections. 2 standard deviations to the right and 2 standard deviations to the left are 4 total standard deviations. So that's 16 divided by 4 is 4. So each of these is 4. And let's just double check. So add 4 is 79. Add 4 is 83. Add 4 is 87. Add 4 is 91. Perfect. It worked. Okay, so that would be my standard deviation. All right, I got 2 more to show you, and then I'm going to show you how to do this in the calculator. On a standardized test, the mean is 73. All right, so I'm going to put that mean in the middle, 73. The standard deviation is 7. If 1,000 students took the test, how many scored between 73 and 80? All right, so my standard deviation is 7. So 73 plus 7 is 80. I want to know how many people scored between 73 and 80. That's 1 standard deviation. All right, 1 standard deviation was that 34.1%. So all you're going to do is take the total number of students times it by 0.341, because I'm going to change that percent to a decimal. So 341 students scored between 73 and 80. All right. Next one, on a standardized test, the mean is 92. Now this one I don't have the curve for. We can draw it. You can always draw your own curve. Of course, I didn't draw it as nice. But the mean is 92. The standard of deviation is 3. And 40 students took the test. All right. How many are expected to score between 89 and 95? Well, if I add 3, that's 95. And if I subtract 3, that's 89. All right, so basically when I'm talking between 89 and 95, that's 1 standard deviation below the mean and 1 standard deviation above the mean, right? 1 standard deviation is 68.2%. So all I'm going to do is take my 40 students and times it by 0.682, and that comes out to 27. So 27 students would score between 89 and 95. All right, now we can use our calculator to help us out. So here's how it works. Using the calculator to find probabilities for the normal distribution. You're going to press second and then VARS, all right? And then you're going to select number 2. It says normal CDF. Now when you do that, it's going to ask you for the lower, that's the lowest number, the upper number, the mean, and the standard deviation. So this is the mean, but the mean for the population. So I got the lower score, the upper score, the population mean, and the population standard deviation. So they have to give me all of that information, and then I just hit enter. Now when you do it on your real graphing calculator, actual words lower, upper, and the mean and the standard deviation and that pace comes up. When you do it on a calculator on your phone, you're going to do the same thing. Second VARS, select number 2, but just parentheses come up. So these words don't come up. You're going to have to know to put them in. Now the number that you get as your answer is the probability of that score in that interval occurring. All right, so let's try one. Given a normal distribution of values for which the mean is 70, the standard deviation is 4.5, use your calculator to find each of the following. So I want the percent of values that are between 65 and 80. So I'm going to hit second, vars, the VARS. Then I'm going to hit normal, CDF. Now when you do it, it's going to say the lower. The lower number is 65. That's the lowest. I want the numbers between 65 and 80. The upper number is 80. The mean is 70. And the standard deviation is 4.5. Okay, and then you're going to hit enter. So let's try it. So I got my calculator. Let's clear this. Let's quit that. Quit. Clear. There we go. So second, vars. All right, I want to scroll down to number 2 that says normal CDF. Now when you do this, it's actually going to say lower, so you're going to know to put the lower number. When you do this on this calculator here, it doesn't say that. So I got 65. Oops, see, a lower bound. Oh, I got to put, so it's a little bit different. So on the graphing calculator, you're going to hit enter. I think I'm probably going to have to hit a comma in between them. Let me find my comma. See, now it's showing me what to put in since I didn't do it right. So second, vars, and let's try it over again. So I got, whoops, let's clear that. That's a mess. Second, vars, all right. I'm just used to doing it in my regular calculator. So I got 65 is the lower. I'm going to hit my comma. Then I have 80 is the upper number. And again, comma. You won't have to hit the commas if you're using the graphing calculator. 70 is the mean, then comma, and then 4.5, and then close. Whoops, I didn't get the 4.5, did I? 4.5, and then I have my parenthesis, enter. So I get, see how I got 0.8536. No, I got a problem because that's not what I got on my paper. You should get 0.6585. And I'm not sure why it's not giving me what I want. I'm just looking at the numbers that I have in there. I don't know why it's not working. All right, but if you're doing this on a regular graphing calculator, that's what you'll get. Not that. So let me just go back. Where's this? All right, so if you do that in the regular graphing calculator, you should get 0.6585. So as a percent, it's 65.9%. Okay, so I'm just going to write it down since the calculator here doesn't seem to be working. I will try it on the calculator app on my phone and see what happens. Anyway, how does it work if I want the numbers that are less than 62? What's my lowest number? My upper number is 62, but I have to figure out what my lowest number is. So second, vars, normal, CDF, so number 2 is the second thing I'm going to pick. My lower number, since there is no lower number, is just going to put 0. Or you could just put like a really, really, really low number, like negative 99999. I see some people do that. I see some people use like a negative, something to the negative power. But 0 is perfectly fine. I want numbers up to 62, or less than 62. 62. 70 is the mean. 4.5 is the standard deviation. So if I put that in my calculator, I get 0.0377. So that's 3.8%. Okay? Percent of values greater than 82. So again, second, vars, normal, CDF. So 82 is the lowest number. I don't have an upper number. I usually just put a whole bunch of 9s as my upper number. Okay? 70 is my mean. 4.5 is my standard deviation. And I get 0.00380. If I move my decimal 2 places, it's 0.38%. So that's very, very low. It's not even 1%. It's under 1%. Okay? If 95% of the scores on a standardized test range from 78 to 92, what could be the standard deviation? 95% is about 2 standard deviations. All right? But 2 standard deviations, it's 2 standard deviations above the mean and 2 standard deviations below the mean. So I'm going to do 92 minus 78. And I did this one before. I divide by 4. So my standard deviation is about 3.5. All right, each year the College Board, some of you have taken the SATs. College Board publishes SAT scores and the standard deviation for students taking the test. SAT scores are normally distributed. Assume for a group of students that the mean SAT score is 500 and the standard deviation is about 100. All right, find the score that is 1 standard deviation above the mean. Again, we can just use our calculator for this. So we're going to do, well, actually, I don't need my calculator for this. This is super easy. What's the score that's 1 standard deviation above the mean? Just take the mean and add 1 standard deviation. Done. That's it. Find the score that is 2 standard deviations below the mean. So mean is 500 minus 2 times the standard deviation. That score is 300. What percentile would a student be in if he scored a 500? Well, a 500 is the mean, so that's the 50th percentile. What percentile would a student be in if he scored a 450? Well, this one we can use our calculator for. So I'm going to hit second, vars, right, and the normal CDF, which is number 2. The lowest number is going to be 0. The upper number is 450. The mean is 500. And the standard deviation is 100. So that's what's going into my calculator. And it's going to get 0.31. So it's the 31st percentile. Because I get 0.31 when I do that. All right. Same thing. What if I want to know if I got 750? What percentile am I in? So second, vars. And if this is a part 2 question on your regions, you can actually just say calculator and put the numbers like I would write lower 0, upper 750, the mean 500. The standard deviation 100, and that gives you 0.99, so it's the 99th percentile, because that's a really high score. The highest score on the SAT is 800. In 2007, approximately 1,500,000 students took the SAT. How many of them would be expected to score between 4 and 500? So it's going to be, for all of these, second, vars, normal, CDF. So the lower score is 400. The upper score is 500. The mean is 500. And the standard deviation is 100. We actually already know this because we saw it on our normal distribution. Remember, it was 34.1%, so 0.341. My calculator gives me the same number with a couple extra decimals in there, all right? But I don't want to know the percent. I want to know how many students. So you take this percent, and you multiply it by the 1,500,000 students, all right? And that comes out to be 512,017 students. So after you get the percent, you have to multiply it by the total number of students. Same thing for this. Lowest score, I'm using my calculator, 300. Upper score, 400. Mean, 500. Standard deviation, 100. So I get my percent, but just times that by the 1,500,000 students, and there's about 203,858 students. All right? Just to see something else. heights of 16-year-old teenage boys are normally distributed with a mean of 66 and a standard deviation of 3. If Jabari is 72 inches tall, which of the following is closest to his height's percentile rank? So I'm going to use my calculator. I mean, I can use that normal distribution, but I think the calculator will just, boom, give you that answer. So the lowest score is 0. His score was 72, so that's the upper. The mean is 66, and the standard deviation is 3. And then I hit enter, and I get 0.977. So basically, he's in the 98th percentile. Soda in a soda can is normally distributed with a mean of 12, a standard deviation of 0.6. If 250 soda cans were pulled by a company to check the volume, how many would be expected to have less than 11.1 ounces? So that's going to be the upper score. So calc, second, bars, and I'm just putting in 0 is the lower, 11.1 is the upper, the mean is 12, standard deviation is 0.6. That gives me 0.0668. That's the percent, but I want to know if there are 250 cans of soda, how many cans of soda would have less than that 11.1 ounces. So I'm going to take that and I'm going to multiply it by 250, and that comes out to be 16.7. So 17 cans of soda. All right, and that was it.